All right, welcome back. So I think what I want to do next is I want to do a review of the right-hand rule because, this is one of the things that's a little tricky about switching to online learning. This is one of those things we do 5 minutes at the beginning of class for about 3 straight lectures, and everyone eventually gets it. But here, you kind of see it once, you move on, and then it never really clicks in. So for that reason, I want to do a quick review and just try and summarize how this all works. So the first thing is to clarify the directions. One thing that gets people a lot is which direction is up and which one is in. So basically what we want to do is we imagine that you are looking at the sheet of paper here. And so that means that up the page, this is up, this is down. So going up the page is up, down the page is down. So this is right, and this is left. All right, piece of cake, right? So now the next trick is into the page and out of the page. So that means if it is pointing into the page, so hard to see here, but my finger is pointing into the page, our symbol for that is an X. So that means it is going into the page. It's like you're looking at like the crosshairs of a back of an arrow. So the arrow is pointing into the page when you see this. So this is into page, and this is out of page. So when we have a dot with a circle, that means that you're seeing sort of the tip of the arrow. So it's pointing out of the page and straight at you. So I think that's what gets people, because what you mean by up and down can be a little bit vague. So what we mean is you are looking at the piece of paper or the screen right in front of you. So up is going up the page, down is going down the page, or up the screen, down the screen. And into the page, so that's the X, so going in, and out of the page is the circle, so it's pointing out. All right, so okay, so now we want to do some right-hand rule questions. So in this case, we've got a Lorentz force, and we want to know a positive charged particle that's moving to the right, and the magnetic field is pointing into the page. So to do this, we take our right hand, and we point our right hand is pointing to the right here, and then our middle finger, so that is going to point into the page. So the X tells us that the magnetic field is into the page. And so the force is perpendicular to this. So that means the force here is pointing up. So in this case, the force is pointing up. All right, let's try this next one. So in this case, now we take our pointer finger. It is pointing in the direction of the velocity, so it is pointing up. Notice it is a positive charge. So it's pointing up, and then the magnetic field here is pointing to the right. So that means our middle finger should point to the right, and that means my thumb is now pointing into the page. So in this case, velocity is up, the magnetic field is to the right, and so that means the force is into the page. All right, and we've got a last one here. Move my camera a touch. So in this case, we have a complication. This time we have a negative charge. So the previous two, it was a positive charge. So that means that basically the right-hand rule told us the direction of the force here. So with a negative charge, we can do it 2 ways, but probably the simplest way is to find out what the force would be if it was a positive charge, and then because it's negative, it will point in the opposite direction. So to do this, we take our right-hand rule again. So here our velocity is into the page, so now it's pointing in. Our magnetic field is to the left, and so that means our thumb is pointing up. So notice, all right, index finger into the page, magnetic field to the left, thumb is pointing up. However, it's a negative charge. So this is the direction the force would be if it was a positive charge. Because it's a negative charge, that means that the force will point down. Okay, so yeah, this is one of those things you just have to practice a bunch of times. I think if you do it a few times, you should be in pretty good shape. We've got lots of time till the exam, but I wanted to kind of clarify. I think this what we really mean by up and down and into the page, out of the page. I think that's where a lot of the confusion lies, so I wanted to address that directly. All right, so we'll do this, and you'll have a question on this, and next we'll look at Ampere's law. Good luck.